Now we will see work done by spring or work done by spring force. We know spring obeys Hooke's law. What is natural length of the spring? When energy stored in spring remains equal to 0, spring is said to have its natural length. Whenever external force F acts on a spring which displaces spring by x, we write external force equal to F equal to kx, and spring force always acts opposite to direction of external force. So spring force F equal to minus kx. So work done by spring force from x1 to x2, we get W equal to integration F dx equal to minus kx dx, integrating from x1 to x2. Substitute the limit, we can get the final work done. Whatever work is being done in elongating or compressing the spring, same gets stored in the form of elastic potential energy. Remember, if spring is elongated or compressed, in both the cases work is to be done by the external agent, and energy gets stored in the spring in the form of elastic potential energy. Suppose initial length of the spring is L0, that is natural length, and final length of the spring becomes equal to L0 minus x. So in this situation, spring remains in compressed position. So work done by spring force equal to minus half kx square. What this minus sign indicates? In this situation, work is not being done by the spring, while work is being done on the spring. What negative work indicates? Work is not being done by the spring, while work is being done on the spring. So whatever work is being done on the spring, same gets stored in the form of elastic potential energy. So work done by spring in compressing the spring by a distance x equal to minus half kx square, and energy stored in spring equal to plus half kx square. While in this situation, work done by external agent equal to half kx square. Suppose spring move from natural length to elongated position. Suppose initial length of the spring is L0, final length of the spring is L0 plus x. In this situation also, work done by spring equal to minus half kx square, and work done by agent equal to plus half kx square. And energy stored in spring in this situation is also half kx square. Now suppose initially spring is in elongated position and finally in natural position. Suppose initial length of the spring is L0 plus x and final length is L0. In this situation, work done by spring equal to positive, work done by spring equal to half kx square, and work done by agent in this situation equal to minus half kx square. Suppose initially spring is in compressed position and finally spring is in natural position. Suppose initial length of the spring is L0 minus x and final length of the spring is L0, where L0 is natural length. In this situation also, work done by spring is positive, that is equal to half kx square. Suppose spring goes from elongated position to compressed position. Initial position of the spring, initial length of the spring is L0 plus x. Final length of the spring is L0 minus x. Spring moves from elongated position to compressed position. Initial length of the spring is L0 plus x. Final length of the spring is L0 minus x. So initially energy stored in spring is half kx square. Finally also energy stored in spring is half kx square. So there is no change in energy stored in spring. So work done by spring as well as work done by agent equal to 0. Suppose now if the spring moves from compressed position to the elongated position, suppose initial length of the spring is L naught minus x and final length of the spring is L naught plus x. Final length of the spring is L naught plus x. Initially energy stored in the spring is half kx square. Finally also energy stored in the spring is half kx square. So there is no change in elastic potential energy stored in initial and final position. There is no change in elastic potential energy stored in initial and final position. So work done by spring in this situation is also equal to 0.